Now we're going to learn about the applications of the equations of kinematics. The kinematic equations can be applied to analyze the motion of any object as long as the acceleration is constant. There are 5 kinematic variables, and each equation contains 4 of them. Therefore, you must know the values of at least 3 of them to solve a problem. In order to demonstrate the application of the kinematic equations, consider the following problem. A roller coaster decelerates uniformly in order to drop off its passengers. The final run is 100 meters long, and it takes 7.0 seconds from its initial braking to come to a complete stop. What is its acceleration, including the direction? Step 1 is to make a drawing that represents the problem with all of the relevant data or variables indicated. Here we draw a roller coaster with the final run to the platform having a length of 100 meters and the initial velocity v0. Step 2 is to choose a convenient origin and indicate the positive and negative directions. Here we have chosen the positive x-axis in the same direction as the initial velocity. Now in step 3, we write down the values that are given for any of the 5 kinematic variables. The values of x and t were given explicitly in the problem as x equals 100 meters and t equals 7.0 seconds. However, there was a variable given implicitly as well. The final velocity was implied in the statement that the roller coaster comes to a complete stop. In that case, the final velocity equals 0 meters per second. In step 4, we must verify that the given information includes at least 3 of the kinematic variables. In our case, we were explicitly given the displacement x and time t, and implicitly given the final velocity v. So we are ready to move forward with the solution. In step 5, we identify an equation that includes the 3 givens plus the unknown variable that we seek. First, note that every kinematic equation in the table contains the initial velocity v0. Therefore, unless it's the variable you are seeking, it must be given in the problem or you must obtain it. In our case, we must obtain it. Since we have x, v, and t, we can obtain v0 from the second equation. Since the final velocity v equals 0 meters per second, that equation becomes x equals 1/2 v0 t, or v0 equals 2x divided by t, which equals 2 times 100 meters divided by 7.0 seconds, which equals 29 meters per second. Our final step, step 6, is to solve for the unknown variable we are seeking. In our case, it's the acceleration. We now have 4 variables, x, t, v, and v0, and have multiple options for calculating the acceleration. In our case, 3 of the 4 equations will work. Let's use the first equation. We have v equals v0 plus at. Solving for the acceleration gives a equals v minus v0 divided by t, which equals 0 meters per second minus 29 meters per second divided by 7.0 seconds. This equals negative 4.1 meters per second squared. Now we must ask, does our answer make sense? We have found that the acceleration is negative. It's in the negative x direction, and also opposite to the initial velocity, as the term deceleration had implied in the problem statement. So our answer does make sense. You will always need the values of at least 3 kinematic variables to solve a problem. Many times the problem statements contain implicit data. For instance, phrases in the problem statements such as comes to rest or stops implies that the final velocity is 0. Starts from rest means the initial velocity is 0. Moves with constant velocity means that the initial and final velocities are equal and the acceleration is 0. Finally, the term deceleration means that the acceleration vector points opposite to the velocity vector. In future topics in kinematics, there will be other such phrases from which we may extract implied information. Finally, you're going to encounter many different types of problems in your study of 1- and 2-dimensional kinematics. A basic strategy to tackle these problems is summarized in the steps we use to solve this problem. They are: Step 1, make a drawing that represents the problem. Step 2, choose a convenient origin, and also choose convenient directions for the positive and negative directions. Step 3, write down the values that are given for any of the 5 kinematic variables. Step 4. Verify that the given information includes values for at least 3 of the kinematic variables. Step 5. Choose from the 4 kinematic equations the one that includes the 3 givens plus the unknown variable you are seeking. And finally, Step 6. Solve for the unknown variable.